Oscilloscopes are complicated instruments, but I'll run through in this video the absolute basics of trying to use an oscilloscope. So an oscilloscope is a machine that plots voltage versus time. So we have vertical axis here corresponds to voltage, horizontal axis corresponds to time. Oscilloscopes will usually have two or more channels, and there will be a little plug like this associated with each of the channels. So ideally you want the little color, for example here is red, to line up with the color for that channel, so that this gives you a hint when you're kind of fiddling around in your circuit trying to actually plug this in. There will be a ground plug that looks like this, and then there will be a little signal plug, and you kind of pull the plastic back to reveal that little plug, and you kind of hook that onto the wire that you're trying to measure on your circuit. Now, as far as a test mode, oscilloscopes will pretty much always come with this probe compensation mode, which is actually generating a square wave. So it's indicated here. This should be a square wave, 5 volts, 1 kilohertz. So I can actually just plug my probe into there, and I can see now a square wave. Now this one is already set up properly, but let's suppose it looked a bit funny and it wasn't triggering properly, and you kind of see this thing scrolling past on the screen. The first thing you need to set up is the trigger level. So you should have a look at the trigger settings in case a previous person has been fiddling with them. So you want to make sure that your trigger settings here look correct. So in particular, I want to trigger based on a single channel. So I would make sure that that is selected here as single. I want the trigger source to be channel 1, because that's the thing that I've connected to my instrument. I would like DC coupling. You pretty much always want DC coupling. It means that you can measure the absolute value of the voltage, and in particular I would like the time reference, the trigger, to be on a DC coupling. I would like to trigger on I can choose the rising edge or the falling edge, let's say the rising edge, and then I select the level. So by adjusting this trigger level, you see that this will now trigger, so it will start the measurement at the rising edge. So when the rising edge of the voltage crosses this value here is actually when this will trigger. So if I go again above this waveform, you see we've kind of lost the trigger, we've lost the time reference. If I now come down so that the signal does cross that threshold, then it will properly trigger. The amplitude is controlled here by this knob that says volts per division, and it's displayed here in red, so this is 2 volts. So you see if I adjust this, that went to a large value. I'll bring this back. So here you have 2 volts, that means 2 volts per division. So a division is where these dotted lines are. So I can see there's 2 volts to here, 2 volts to here, and then 1 volt kind of halfway up. So I can see that's a total of 5 volts, which I can read based on that scale. The horizontal axis is controlled by this seconds per division here. So this is the value here, m of 500 microseconds. So that means there's 500 microseconds per division. So it's 500 microseconds across to the first dotted line, and then another 500 microseconds to the next dotted line, and so on. There's a setting for adjusting the vertical position, and so what this does is basically just slide it up and down. So you can kind of use this to, if you've got multiple things on the screen, you can kind of get one of them out of your way. You press the button in to zero it, so put it back to a 0 reference. The position is indicated, the offset, horizontal offset, is indicated by this little channel 1 here. That means that the 0 point for the red channel is kind of down here. Press it in to 0 it. There's also a horizontal position, so you can shift where the trigger point is. So the trigger point is shown here with this little T at the top, and again press it in to 0 it. So you want the trigger, you want to see equal parts before and after the trigger point that you have selected. An important thing to recognize with the multiple channels, so the ground on channel 1 and the ground on channel 2 are actually connected together inside the oscilloscope. So if you're trying to measure different voltages on your circuit, if you try and put these at different points, these two ground pins at different points, well then you're actually shorting those points together through the body of the oscilloscope, so you can't ever do that. If you want to measure the difference between 2 points, then you need these to be a common reference, and you need the 2 probes to be the 2 different points, and then you can use the math functionality to calculate channel 1 minus channel 2, for example. There are also special probes that you can use for differential measurements, but these are just standard single-ended probes. So what I'm going to do is now put both of the channels back onto this little calibrate pin. If I would like to show channel 2, then I press the channel 2 button to toggle it on or off. Let me just move that down so I can see both at the same time. So I have now these 2 different channels which are displaying, in this case, the same thing because I have hooked them up to the same node for measurement. I'll press that in to zero it again. Now, a few other sort of traps for the unwary, things that might catch you out if other people have been fiddling with these instruments. Oscilloscope probes usually have attenuation settings, so it says here times 10 or times 1. So this is to do with the resistance of this probe. Now, most of the time you want 10 times attenuation. That's kind of a good default setting. But whatever you choose here, you have to tell the oscilloscope which setting you have chosen. And so I do that, I go into the channel mode. So for example, I want to look at channel 2, so I press channel 2 until I get the menu for that channel. I press the button for probe, I choose attenuation, and I scroll through to make sure that I have 10 times is selected, and then I press on that knob to actually lock that in as 10 times attenuation. So yeah, you just need to make sure that that setting lines up. Another point is the difference between AC and DC coupling. So if I choose AC coupling, then what happens is it kind of shifts down, basically subtracts the mean from that voltage. So AC coupling just means that we're looking at changes in voltage, not the kind of absolute reference. So the mean value has been subtracted away is kind of how to think of it. You probably don't want AC coupling unless you're doing a measurement of, say, a really, really large voltage and you're looking for a small perturbation on top of that large voltage. Most of the time, you actually just want DC coupling, so make sure that you have that selected, or else you're not going to be able to get these kind of correct voltage references. Another point that can be a little confusing is if your trigger modes are set strangely. So on this particular oscilloscope, it is possible to have different trigger modes for each channel. Now, I think this is kind of crazy. You pretty much never would actually want this because it means that the horizontal time axis is different for the 2 colored lines. Which is kind of crazy. So if you've got the trigger, so I press trigger menu here to open this up. So trigger menu, and the type here is set to Alt Edge. Then I have now different trigger points for each of my channels. So I can select, for instance, the channel 2 trigger, and then when I adjust that, I'm now setting the trigger point for, let me try and get this set. The trigger point for my second channel, but you see I now need to go back in and change the trigger point for my first channel, for the red one, to make that work. I think this mode is kind of crazy, so you should make sure, unless you really want them to be triggered separately, you should go and choose single here, and then it means that the time axis for these 2 different colored lines is the same, because that's quite surprising if that's not the case. So there's kind of the absolute basics of how to use an oscilloscope. There's a lot more things that you can do. They're really quite sophisticated instruments, but that should be enough to get you started. So make sure that you have the correct attenuation mode selected on your probe. Make sure that you've told the oscilloscope the attenuation mode that you're using. Make sure you have your trigger set up, or you want a single channel for trigger only, so single mode here. And you want to make sure that you have adjusted the display, so the time scale and the voltage scale for the signal that you're trying to look at. There's also an auto set button that you can press. It's kind of nice to know about, because if you press auto set, then it will actually kind of come up with something that kind of visualizes what you're looking at. But if you don't understand the instrument, then you can kind of press auto set and hope you see something, but you can't really interpret what you're doing. So here, for example, it's actually put different vertical offsets for these two signals. So this does not mean that the red voltage is much higher than the yellow voltage. It's actually given them different offsets, and you can see that here with the 1 and the 2. I could press these vertical positions in to reset them back to 0, and of course I'm going to need to adjust my trigger settings as well. So again, it's changed it to Alt here, which is strange. I don't want that. I want a single type of trigger, and I can set the level to be that we trigger when the voltage rises, rising edge, that it triggers when the voltage rises past the point that I choose here with this line. So there you go.